Here's what we're gonna do now, okay? So now we gotta get into the four quantum numbers. I have to define to you the four quantum numbers so that we can then start applying the said four
Straight up.
quantum numbers.
We don't, that is what I'm talking
So,
about.
Wait.
What did we write down just now?
A lot.
I gotta get my legal pad out, Mr. Hall.
it should already be out.
Well,
I'm
never,
helping a student.
how was I supposed to know that we're gonna write notes today?
So the four quantum numbers, really? Am I here?
We don't usually,
You
you
didn't
know.
mean that.
need to do that.
So out of the four quantum numbers, we're gonna start
We never
at the
said
top and
that.
work our way down. So number one is.
Hey, wait, I bet I know what it is.
You might just wanna take a
I
picture
bet
that's
you I
like
can guess.
I guarantee I can guess it, hold
quite a
on.
bit.
Principal quantum theory
Next.
numbers.
So the first one is a principal quantum number that's abbreviated with a lowercase n. Now, when you look at the principal quantum number is extremely important to us because of what it will tell us. So when you look at the principal quantum number, it tells us the main energy level. Also known as the shell.
Boiling my bones as we speak. The fact that we might have
So that's what it tells us, but it just doesn't tell us some information, it also shows us some information. So some things that we can see with this. This will tell us the row off the periodic table. So it shows the row of the periodic table.
Hey, Todd, do you work today?
Yeah.
You should like take me with you.
Okay.
Okay?
So no, what?
Now, from all of that, it does have certain values that it can be. Okay? When we look at the principal quantum number, it has a possible range. The possible range goes between 1 to 7. But it must be a whole integer. In other words, it has to stay a whole number. Let's just say it that way, whole number. So nobody gets confused. So it can be 1, 2, 3, 4, 5, 6, or 7. It cannot be 1.5. Okay? What this is, the principal quantum number, is the energy level. Today is going to start making a lot more sense to you, and we're going to join some things together. All right? Okay. Now,
$20 if it's angular momentum quantum number.
deal. Say
No
what
way.
this.
Hey,
$20 that it is,
spin quantum number.
never mind. He was right.
who's gonna pay me?
What do you mean? I thought you were paying me.
No, wait, no.
It's angular momentum quantum number, man. They get the 20 out.
So I don't think you understand how bets work.
He's a gambling man.
I'm a
Look at him
gambling
go.
man.
You got to know when to hold them. You gotta
I
know when
believe
to
if I
hold 'em.
went to Vegas with $30 in blackjack, I could win the whole house.
Yeah. All right. Anyway, angular momentum quantum numbers. So the angular momentum quantum number is abbreviated with lowercase cursive l. Now, when you look at the angular momentum quantum number, it also tells us some stuff. So, one thing it does tells the shape of the subshell. The shapes are familiar to you without them being familiar to you. The shapes will revolve around one of four.
So known as a square.
Right now, I feel like getting up and like standing there and charging myself like I'm Goku and then running around in circles.
Mr. Hall, these are crazy.
The shapes are either S, P, D, or F.
I have the perfect picture of
This
all of them.
are the subshells.
Does that stand for square?
No.
Oh.
Here, this is what they look like. Tanner, you get the look.
So, well, I'll explain it to you. I actually do.
I don't like them.
So,
Not a fan.
the S and P are easy to understand. So when we talk about S, I talk about spheres. So it's like a sphere. We talk about P. P's are what we like to call, I like to call peanuts.
Okay.
They look like that. And then we go into D and F. I'll let Kenzie show you all the pictures off
Do
her
you guys wanna-
Chromebook, because I'm gonna tell you right now, I'm not drawing D and F. Because D and F changes and becomes very, very complex.
Kinsey, can you draw it on the board?
There you go, guys.
Do we have to know what they look like?
S
No,
has
but I just
one,
want you to
G
see it
has
so you know.
3, D has 5, 7, F has 7.
That is badonkerdonk.
It's a good picture.
Very good.
Oh.
Parading it around the room.
Now we deal with what it shows, okay? Now what this will show us, we have the row off the periodic table. This one tells us the block
This is helpful.
on the periodic table. You want to know where that comes from? All those images, they're mathematical calculations and graphs created by mathematicians. So it shows the block on the periodic table. You're already familiar with that. That shouldn't freak you out. Why? I've showed you S, P, D, and F block. You know which one is which.
Straight up dog.
What's your favorite block, Mr. Hall?
Probably the Bloods.
You like,
Probably P block.
Huh.
that's a good one.
I like that
And the S block's got alkali metals in it. It's hard to choose. I'm
Which
sorry.
I like
Which
the
one has
big block
broke?
'cause it's in the middle.
Bismuth? I'm a bismuth fan.
D honestly is like the
All right,
best.
here's the one. Possible ranges. Here's the one that kids struggle with, okay? So here's the one that I want you to slow down, I really want you to focus in. The possible range for this is dependent on the previous one.
Straight up.
So it can go from 0 to the quantity of n minus 1. What is n? It's the principal quantum number.
Excuse me.
Understand, there's two different things we would do with the four quantum numbers. One, you will determine if a set of quantum numbers can exist. For that information, you will use the possible ranges. Besides that, a second thing we do is you will tell me the four quantum numbers of an element off the periodic table, and I will give you the four quantum numbers, and you would tell me the element from the periodic table. whenever you are doing the second scenario with what we would do with them, the block tells you what L is. You have 4 possible blocks: S, P, D, and F. The value for L, if it is S block, is 0. The value for L for P is 1. The value for L for D is 2. The value for L for F is 3. Understand, this is where everybody gets tricked. It's just pure memorization, there ain't no other way to give it to you. You use that, it's in the box, the purple box, when you are determining the 4 quantum numbers for an element, or you are determining an element from the 4 quantum numbers. When we use the possible range is when you are going to determine if a set of quantum numbers can or cannot exist. Everybody understand? Cool. I will do examples of these. I should have added to that.
There's no way that someone could break out of prison with a plastic knife.
Y'all ain't got no room after this now, do you?
Huh?
I will add to it later. Okay. All right.
Yeah,
So,
how much more are we adding to?
it's not much. It's something you already know without you already knowing it.
That seems very contradictory.
Oh, really?
I'm
Now,
afraid.
we're going to step from the angular momentum quantum number. We're going to the third quantum number. The third quantum number is the magnetic quantum number.
This is my favorite one.
So the magnetic quantum number it does tell us something. Tells orientation of the orbital. This may be confusing.
There seems to be something where
Goes.
that goes to
Christmas
the walk of shame.
So, the orientation of the orbital. This seems a little confusing to you, trust me, I'm going to show you something.
Sorry for the interruption, teachers, but just a reminder to pick a student that's trustworthy to bring me your absences and lunch count every morning. It would be greatly appreciated.
Why do they
Also,
get
it
trust?
would help tremendously if you would use the sheet that I originally gave you at the beginning of the year to keep the counts on. That's just much easier to go by. If you need one of those, just let me know.
Why do they have to be trustworthy? What are you gonna do, steal the absence sheet?
Oh, I'm gonna steal that thing and write so much.
Might go to the bathroom, you know, roll it up, vape with it.
Vape with the absence sheet?
You don't know what these kids are doing nowadays.
I saw Swin in there with bug spray the other day.
All right. Also, what it shows.
Times are tough.
Are you being real?
I will say this, I guess Phillips did a real good job because I haven't heard nobody talking about mice or anything, or termites. All right, what it will show us, what this shows us is the column on the periodic table.
Such a lame one to like pattern. Column.
What?
You said this is your favorite one?
Well, you know what? How about you mind your own business? You know what? Magnetic quantum number has everything that angular movement has, but better.
Have what?
Angular movement.
Angular movement?
Angular momentum.
What if I did the abbreviation of
But
momentum?
I feel like
Moment.
Mom.
Angular mom.
Possible range.
That's so gangster of you.
so. Do we use these numbers to find elements on a periodic table? This is what you're setting up for? Okay.
And then the real fun part comes, is like I can really pull on you and I can actually give you ions and then have you figure that out. Oh, it's so
Give us
fun.
what? Iron lung?
Ions.
Oh.
Hey.
So possible range
Clown college.
goes from negative L
You can accept me.
to positive
They,
L.
instead they. accept
That's
my
negative
parameters.
angular
They're
momentum
called-
quantum number
Oh,
to
really?
positive angular momentum quantum number. Hey,
Unlikely.
here's the key to this you have to remember. Principal quantum number started as a whole number, right?
Winter's college.
Angular momentum quantum number is dependent on the principal quantum number. So what must the angular momentum quantum number be? Whole number. The magnetic quantum number is dependent upon the angular momentum quantum number, which is a whole number because it was dependent on the principal quantum number. Which therefore means this must also be a whole number.
Whole number.
Now, what you have to see is what will take place.
Something
It
crazy.
goes from negative angular momentum quantum number to the positive angular momentum quantum number. So what we will see is whenever we have a value for L, we have a certain value for M sub L. So whenever we look at, like Kenzie was saying, whenever we're going to use these in finding an element, or we're going to use these to find 4 quantum numbers, there's going to be values with these. That's when we're using this, so I have a 0, 1, 2, and 3. Now remember what blocks these are for. These still are for a certain block. S, P, D, and F. So when you look at this, look at L. L is 0. What's the possible range for M sub L? Negative 0 to positive 0, which is
0.
0. P is 1, right? So we go from negative 1 to positive 1. But we go whole integers. So negative 1, 0, 1. Hey, a quick question. Time out on the field before I forget. Hey, I always forget at this point. Somebody remind me, how many of those dashes did we have for an S subshell? Whenever we did the orbital notations, how many dashes did the S have?
1.
Okay.
Holy crap.
So it had 1,
It
right?
comes full circle.
Okay.
What?
Hey, so I forget. How many dashes were there for the P?
It was
Three
3.
was wrong.
Okay.
And it's gonna. Oh my
Okay.
Don't tell me, Mr. Hall.
Well, that's funny.
Ah!
That's gotta be a
The
coincidence.
electron and the 1 is
Oh,
the
okay.
positively charged electron.
Fork broke.
I'm so scared.
I didn't expect it.
Okay. It's just a freaky
This
coincidence,
is
right?
a Kevin moment right now, guys.
This has to be
So D
false.
block is 2, so negative 2 to positive 2, right?
Absolutely.
So negative 2, negative 1, 0, 1, 2. How many of those dashes were in the D blocks again? 5. Holy smokes.
Oh,
It's gotta be a coincidence. Yeah, man. It's just,
absolutely.
Something.
Okay.
Somebody's betraying us.
look, F, right? F. F is 3. Okay. Negative 3 to positive 3. Negative 3,
7.
negative 2,
This is so
negative
gangster.
1, 0, 1, 2, 3. How many dashes were in the F?
So,
My gosh! It matches up!
How does this
How many
happen?
coincidences can we have before it's not?
It's not one.
I can't believe.
If it sounds like a duck, if it walks like a duck, if it eats like a duck, if it waddles like a duck, it's a duck.
Well,
Unless it's in a box
What?
That's what I'm
and
saying.
it's in the quantum realm, then it's clearly a cow.
That doesn't sound like Schrodinger's thought experiment.
What I'm saying with these is you guys are already familiar with these. Whenever you guys were doing these, we looked at it. So let's say like we had the 2s.
so how are they gonna like not give people?
The magnetic quantum number is all about
They can't even cut
orientation.
plastic.
Do you remember, hey, y'all remember seeing the image that Kenzie walked around with? They all had different orientations to it. That's what this is.
Thanks.
S is a sphere. Well, spheres, doesn't matter how you change the orientation, it's just a sphere. So that's a 0 orientation. What changes is whenever you go to P's. So let's say we did 4P. And I'm just choosing random ones, okay? This applies for all of them, for all the P's. Guess what this first one is? -1. Guess what the middle one is? 0. Guess what the end one is? 1. Guess what happens for the 5 in the D block, in the D subshell?
No.
Tell me
Don't
about
tell
that.
me.
I don't know.
1, 2, 3, 4, 5. What? So -2, -1, 0, 1, 2. You didn't even know it, but I was laying the foundation for this. Guess what happens in the F? 1, 2, 3, 4, 5, 6, 7.
Bad.
They're tired.
-3, -2, -1, 0, 1,
I
2,
mean,
No,
you're-
3.
I'm proud of that one.
No.
Never mind.
You should not be proud
I'm
of that.
fine.
Again,
Wait.
when are we going to use this? When you're dealing with elements off the periodic table or form quantum numbers and you're trying to find an element on the periodic table. That's when you're going to use those. Now, to do this,
No.
you guys want to start hard and then go easy?
No.
hard.
You want to start
straight
easy
in.
and go
Let's
hard?
start hard and stay hard.
This is a pattern.
Ah.
I'm gonna start here, okay? I've ran out of room. I'm
Erase.
gonna put the spin quantum number here. Okay? It's the 4th one. Number 4. Spin quantum number.
Hey, can we agree that that's a really cool name?
I'm changing my favorite to spin.
Yeah, I think we do.
Alright, the spin quantum number. The spin quantum number is going to do some stuff for us.
Wait, what's its like symbol?
Oh, my bad. Good point. That is N sub S. So the spin quantum number tells us something, okay?
Charlotte, what you gonna add on there?
It tells us, I told you I'll add on to it later on. What I need to show you, you already know without knowing. It tells us the spin, the direction of the spin of the electron.
That is so gangster.
Yeah, I feel like this would be very hard to learn if we didn't do it the way we did it. Like the backwards.
It is.
Like, I don't. This would
It
be-
is. I used to, for the first 3 years of me teaching, I taught this way, this first, then did the configurations. And I found out that I spent a good 2 weeks and wanting to pull my hair out because kids just couldn't get this. These values are just accepted. And then whenever we get to electron configuration, they're like, oh wow, it connects now, cool, that's awesome. So I flipped it one year and it went so much smoother. Like even with electron configurations, I still looked at you guys and I told you, I said, just accept this. But you were more apt to do it because it's a whole lot easier to understand.
It was a little puzzle.
That's
This
so
also
gay,
is a
yeah.
puzzle. Shows,
That's so.
okay? What it shows to us is the elements on the periodic table. Now this is after we've narrowed it all the way down. So what it really does is it really shows us the first half or better, make that better. The first half or second, spell the word out, Kevin. Of the block. Now, it's very important to know that the possible range for this is only two options. The possible range that we see is +1/2 or -1/2. That's all it can be. What do you think the up arrow is?
Less.
+1/2. What's the down arrow?
Mine is.
It's the -1/2. It's the -1/2. Now, we're going to start easy, and then we'll go into making things apply. We will have to break the periodic table down again, so I will be giving you another periodic table.
I no longer believe that people can escape prison with plastic
That's not
things.
looking good. She's not canceling.
All right, here is the most simple ones you're going to get from me. This is all I ask you to do, is determine if the set of quantum numbers can exist. That's it. Now for that, I have to give you 4 quantum numbers.
Mr. Alt, is this a yes or no answer? Is there a 50% chance I get it right if I just guess?
Sure, but there could be 100% chance if you actually, I don't know, did the work.
Yeah, but would you count it right if I just said yes?
You're having 50% odds. Really
If it was
nice.
yes, then yeah.
You would? You'd count it like full correct if I just put yes?
So let's say for
No
n,
way.
I have 4, L,
I guess.
I have 3, M sub L, I have -2, M sub S is -1/2.
Can we come back during lunch?
Cool. I'm actually gonna draw out 3, okay? We can go across. Let's do N as 6, L as 5, M sub L as 6, M sub S is +1/2. Let's do N as 8, L is 2, M sub L is 0, M sub S is +1/2. So, this is what I like to do. Whenever you're determining if the set of quantum numbers can exist, what you're doing is you're looking at the possible ranges that they can be. Remember, what is everything dependent off of? The possible range of the principal quantum number. The next one's dependent on the next one. Okay? So, here's how you do this. You start with the principal quantum number. and work your way down. So, n is 4. Can n be 4? Possible range, n can be from 1 to 7, but it has to be a whole number. N is 4, so it can be 4. Good check there. Go to the angular momentum quantum number, L. Now n is 4, so L can go from 0 to n minus 1. N is 4, so 4 minus 1 is 3. So that's 0, 1, 2, or 3. L is 3. Can it be 3?
Yeah.
Yes. M sub L is negative 2. M sub L's possible range is from negative L to positive L. So it can go from negative 3 to positive 3. Negative 2, does it fall in that range?
Yeah.
So it's good. Spin quantum number can either be plus 1/2 or negative 1/2. It's negative 1/2. Can that exist?
Yeah.
This is a yes. That can exist. Okay? Let's go to the next one. N is 6. Can n be 6? Yes. If n is 6, can L be 5?
Yeah.
How do you know that?
Because 0 to n minus 1,
And what's n minus 1?
5.
Because n is 6, 6 minus 1 is 5. Now, m sub L is 6. Can it be 6?
No.
Wait, why?
Because it's negative L to positive.
Yeah, but n is 6.
But L, it's not, N is not L, Mr. Hall. But you should have learned this in preschool.
Thank you. Thank you so much. Right here's the problem. M sub L cannot be 6. The reason it cannot be 6, M sub L has a possible range from negative L to positive L. So look at what we have. We have L as 5. The highest I can go is 5. It cannot be 6. This cannot exist. Understand how to do this?
So if you stop on that, you don't go down, right?
Nope, there's no point. Why do I need to check the spin quantum number? Magnetic quantum number can't exist. Alright, last one. N is 8. No, N be 8.
No.
Why?
There's 1 to 7. And
Is that it?
Yep.
yeah,
Huh. Well, that's things.
that's kind of a letdown. I was, ready to do the others. But
Understand how to do it?
Yeah.
These are the easiest ones. What do you use in order to figure that out?
Numbers.
We're going to use the possible ranges. You have to know when to use what. I'm going to tell you, there are some of you in this room that are not going to listen to me right now. You're going to let yourself get confused. When do we use the possible ranges? Possible ranges is to be used with determining if the quantum numbers can or cannot exist. Okay? How y'all feeling?
Good.
I threw tons of information at you.
Ah. These need to stop breaking.
One big thing that I've seen kids get tripped up on in the past. You guys should know me. I don't baby you. I'm not about babying my kin kids.
Cuckoo caca.
I'm not.
Milk.
I make a statement. I would stack you up against any kin kid in the state.
And we would absolutely
I
demolish
stand
them.
behind that.
I would literally twerk on that.
They would not,
Okay, that's weird.
after we won, of course.
What I'm saying, what does the principal quantum number show me? What does the principal quantum number tell me? These are questions that very much could be on your quiz on Friday.
I'd rather do the other part. Yes, me.
You have to know the conceptual parts. That's why I spend time on it here in class. You have to know the conceptual. It's not just about the application. I want you to be able to apply it, but you also have to be able to know what these things are telling us. What happens with these are these all combine together to build a big picture. These four numbers combine to give us the orbitals and the locations of the electrons inside of orbitals. And it just keeps narrowing it down. Tomorrow, what we're going to do, whenever you come in here, I will turn it. Tomorrow when you come in, you will either have an entry slip or I'll have some problems on the board asking you to determine if a set of quantum numbers can or cannot exist. Do you think you can tell me whether the set of quantum numbers can or cannot exist?
Easy peasy,
What
bro.
piece of information do you use to determine that?
Possible, whatever. Bro.
Possible ranges. Here's the thing kids get tripped up on every year. Possible range. Can L be 5?
Yeah.
If N is 6, L can be 5.
Yeah.
On the periodic table, will we ever see L being 5? No. What's the highest it goes to on the periodic table?
3.
Who's the 3? My voice cracked like a 12-year-old boy with a computer here right there. You have to separate the two. This is where everybody falls into a trap. I'm literally taking 3 minutes right now stressing this to you so you don't fall into the trap. Please don't fall into the trap. Periodic table, the highest you'll see L is 3. But it is possible for L to be greater than 3. Be careful. Questions?
No. Wait. No.
So gangster.
Wait. What is the direction of the spin of the electron? What does that mean?
So that's telling you whether it's spinning clockwise or counterclockwise.
I didn't even know that.
It's a way of looking at it.
It's like,
You didn't know they spin?
How was I supposed to know?
He said it.
I have to make up for not for just not doing that.
Alright, anyway, on your periodic table, I want to make sure you guys get this, okay?
Quidditch.
So what I'm going to do is I'm going to show you, this is the cheat sheet. This is what you will do on your periodic table to help you figure out the quantum numbers. Okay? So there's certain ones that break down in certain forms and fashion. I give you this, and then we will apply it. So first, everything is still dependent on rows. So the rows still exist here. We're still not leaving the rows. So I want to make sure you get that. First, second, third, fourth, fifth, sixth, seventh. And remember, lanthanides are fitting right here. So that is the, like it's in the 6th row, and actinides are like they're in the 7th row. Okay? Now, breaking this thing down is simple.
I was feeling in the Christmas spirit.
When you're dealing with the quantum numbers and you are starting with them, whether you are trying to find the 4 quantum numbers from an element or you are trying to find the element from the 4 quantum numbers, you're going to not go in order. The first one you're going to go for is the angular momentum quantum number. Remember what the angular momentum quantum number is. The angular momentum quantum number is L.
Ow.
The reason for this is, what does it tell you? It tells us the block. It shows us the block, sorry. Shows us the block. It tells us the shape. So columns 1 and column 2, remember, this is S block. Right? And for S block, if we have S, then L is equal to 0. So if we fall within columns 1 or columns 2, we're in the S block, so that is going to be L equals 0. Now with that, if L is 0, what does M sub L have to be?
0.
Has to be 0 because M sub L is from a range of negative L to positive L. So
Teachers, this is a reminder that if you haven't sent your absence list up this morning, Kathy needs that at this time,
so
please.
from it,
Thank you.
negative 0 to positive 0 is just 0. So this column will be M sub L, be 0, and then this column will be 0. Then we come to the spin quantum number. What fraction do we use when it comes to the spin quantum number?
Positive 1/2, negative 1/2.
So we're doing halves. Guess what you're going to do? Half the block.
Sleigh.
So we're going to split the block right in half.
Here, why don't you look at
This side over here is the plus 1/2.
It's not doing all that.
This side over here is the negative 1/2.
What?
Confusing because the S block, everything's the same practically. Now, let's go over to the P block. Remember the P block, it's columns 13 through 18, excluding helium. Remember helium's over in the S block. So we deal with P block. For P block, remember we start with the angular momentum quantum number. Angular momentum quantum number for P block. If we are in the P block, L is 1. Good job.
Thank you.
So L equals 1.
Just talking to me, Tanner.
What do you mean?
Now,
Look at this.
we got to break down M sub L. If L is 1, then what's M sub L? What's the possibilities?
Negative 1 positive.
Yeah.
Negative 1, 0, and 1. What was the third rule that we used when it came to electron configurations?
1 electron in each orbital.
1 electron in each orbital of the equal energy levels and the equal subshells. Each electron gets 1 hundredth before it gets a second one. You have to keep that in mind because column 13 is a negative 1. Column 14 is a 0. Column 15 is a 1. Why? There's 3 dashes. We got the first, second, third. Everyone gets an up arrow. Then we come back and give down arrows. So we copy and paste. We repeat. Column 16 is negative 1. 17 is 0. 18 is 1.
That's so cool.
It's awesome.
But Mr. Hall, wait a second. Well, how are we going to split it apart?
That's where the spin quantum number comes in. Split it right down the middle. Here, spin quantum number is plus 1/2. Here, spin quantum number is negative 1/2. You got the first half and the second half. Up arrow, down arrow.
Mr. Hall, I think I've asked this before, but I forgot. Why is helium next to hydrogen?
Because helium is, why is it next to hydrogen?
Why is it not?
Because
Like, why
helium
not
is a
there?
noble gas.
Okay.
When we get to bonds, I'll show you guys why.
Is there any way to tell which one's positive?
It has a full first energy level.
One on the
I
left.
think that'd be
Is it always this
sick
one on the
with
left?
You always start with positive.
I mean, it's really convenient that all these blocks have even numbers.
Yeah.
Well,
Have we found element 117, haven't we?
we found them all, but this is the periodic table I've been using for years. Whenever you guys take, whenever you sign up for AP chemistry, there actually is a different periodic table I'll be giving you because it's going to be the same periodic table you'll get on the AP exam.
Like,
Which, by the way, your AP chemistry class is going to be very similar to this.
Yeah. So you're gonna.
So you should sign up for that.
it.
Yeah. We're on it.
Would it make a difference for you if I
Sydney's
told you
gonna sign up.
that you're not gonna fail?
No.
Probably.
What?
What
Why
would
are
make a
you
difference?
taking
What could I do to convince you to
Do
take
you
that
hate
ticket?
him? Why do you hate
No,
Mr. Hall?
it's because Sydney
You hate
will be
Mr.
there
Hall,
next
don't
year,
you?
isn't it?
If you give me
Exactly
guaranteed
what
A
it is.
plus,
That's
Mr.
Sydney's
Hall.
fault. She should have took Kim's last year.
Well, then she could have
could
taken it
take
with
it.
us.
I'm glad I didn't, because I'd rather have this class.
Aw, she loves us.
Wow. Guys, look, I made a,
All right, so here we're at D block.
pencil.
We're at D block. L is equal to what?
What?
2.
D block, L is 2.
Yep.
Yeah, buddy.
You tell him. That's straight up, dog.
Now, from there, M sub L, we go from -2 to 2. So guess where we start? Start at column 2.
Yep.
Start at column 3 and start with -2.
That's what I'm saying.
Column 3 is -2. 4 is -1. 5 is 0. 6 is 1. 7 is 2.
I'm gonna be really mad if they discover element 119.
I said we go to
Me too.
120 and then stop.
Oh, never
It's
mind.
gonna mess up the whole thing.
-2, -1, 0, 1, 2.
Do you think they'll start a new block?
I don't know what they'll do.
They add,
Now.
they only add elements 2 at a time.
What are we gonna do? Spin quantum number. Split it in half. Over here, it's +1/2. Over here is -1/2. Okay?
Yep.
Now we go to F block.
3.
Hooray.
Here's F block. F block gets funny. So F
Ooh.
block. Well, I don't have a lot of room to write. So if we're dealing with F block, that must mean that L is equal to what?
3.
3.
So L is 3, which means that we go from -3 to +3, right?
Yeah.
So let's start.
Let's just send this
-3,
up.
-2, -1, 0, 1, 2, 3, -3, -2, -1, 0, 1, 2, and 3.
Oh, I see the issue now.
No room to write.
Oh no. How split?
Split it right down the middle.
On the middle.
Left side,
2.
+1/2. Right side, -1/2.
I'm making stuff up in my brain.
Yeah, it's okay.
I know what you're thinking. Why in the world, Mr. Hall? I tried to teach you something so that you don't have to do tons of memorization. That's the goal. So, here's what I want to do. I want to show you how this applies. Okay? Trying to leave it so I don't gotta adjust the camera a lot. I should come back here and teach more often. You three are very well behaved.
Thank you. Wait.
Now that he's
You
gone.
three.
The,
What are you
ca-
talking
the
about?
camera was pointing at me, I was scared.
Who's he talking?
They can't hear you at all. Just let you know.
Okay.
I know they can hear me, but
Now,
it doesn't
I
look
wanna
at me,
make
so
sure
it doesn't
I'm
matter
clear on
if
this.
he's talking.
Today is introducing this to you. Tomorrow, guess what we'll do?
Do it.
We're gonna do practice.
Hooray! Yippee,
What is-
yippee.
I'm not gonna teach you anything new tomorrow before the quiz. This is it, but hey, do me a favor. That doesn't mean don't come to school.
Yeah, always come to school, guys.
Yeah,
Mason would
basically.
never miss ever in his life.
All right,
It was on-
Ow!
here's the first one.
Mr. Hall,
So, like,
he
now
had a
back.
come to Jesus moment yesterday in Miss Goodman's. He was taking his test and I hear him whisper, I need to start coming to school.
Yeah.
Well, it's okay. I actually came to have a conversation with him, and it was very funny. He went to the office and checked his attendance. And as I'm coming into Miss Cochran's room, Miss Cochran is having a conversation with him about his attendance, which is very funny because the office is talking about his attendance. Miss Cochran's talking to him about his attendance. Mr. Hall pulls him out of his math class to talk to him about attendance. It was a good attendance conversation yesterday for Mason, wasn't it?
And Mason's here.
Oh,
Look
So,
at, look at
the
that.
first
It worked,
one
it worked.
we can do is from an element, obtain the four quantum numbers. So, for example, I'm going to do sulfur. Sulfur's atomic number is 16. Now, whenever we do this, we're looking for the four quantum numbers.
Was he?
First thing we start with, start on your periodic table, start with the angular momentum quantum number. You're going to find out why. We start with the angular momentum quantum number. S is in what block?
What?
1. Wait.
0.
0. Never mind. S is 0.
S is in what block?
Oh,
S, P, D, or F?
Oh,
It's in P block.
oh, I thought you might.
Sulfur is
sulfur.
atomic number 16.
I thought you meant
It
S
is in the
block.
P block.
S
I
block
thought you
is
meant
not
S
in
block.
the
I was like,
block,
where's
it's
S
all-
block? What do you mean S block
You
is in
bet
P
boozled
block?
me.
S, P, D, or F block.
Okay.
Sulfur's in P block.
So true.
Yes.
I
Okay.
deliberately toned that part out.
My brain.
We're all
So, sulfur's in P block. If it's in P block, what does that mean L is?
1.
L is 1.
We all were so confident. This is so
Now,
easy.
here's the thing. N is the tricky part. N is the energy level. It's dependent on the row. This is the part that I wanted to add to the principal quantum number description yesterday, but you guys had no room and that was my fault. When you're dealing with finding N, you have to remember something.
It's hot in here.
For S and P blocks, N equals rho. For D block,
It's all coming forward.
N equals rho minus 1. For F block,
Who could have seen this coming?
N equals rho minus 2. It still applies. You see, I told you, these things link together. So when we look at N, we're in the P block. So N is equal to the rho. What rho is sulfur in?
3rd.
So N is 3.
That's true.
Now, I have it narrowed down to a row. I have it narrowed down to a block. What I've done is I've narrowed it down to 6 elements. Now I have to narrow it down more. M sub L, magnetic quantum number, that's the column. So look at the column sulfur is in,
-1.
and look at the value for M sub L over it. It's -1. Now I've narrowed it down to 2 columns, but now I need the spin quantum number.
-.
When you look, is it in the first half or the second half of the P block?
Second.
Second.
It's in the second half. So M sub S is a -1/2.
Wow. I can feel the sickness getting worse.
Kind of crazy.
Dying.
Now,
Probably good.
you can do this in reverse. I can ask you to find an element.
Hey guys, I think the kitchen can hold off.
Yeah, he's not in.
He's gonna teach us what x plus 1 plus
He's not
x
even
plus
gonna
1
teach us.
is.
He's gonna talk for 30 minutes and then he's gonna leave.
You guys are doing good, so your attendance is good. You got your assignments in on time. All right, now I'm gonna take attendance.
Hi.
You're gonna ask us to find the element, Mr. Hall.
What's
Yep.
going on in
Extreme-
class?
Extremely rude.
Now,
Isn't it your shop?
here's the thing. Here's the 4 quantum numbers. I'll give you a second to write it down. We're going to work from those 4 quantum numbers, and guess what we're going to do?
Find the element.
To get out.
We are now going to find the element. Where do we start?
With
L.
L.
Angular momentum quantum number.
You're so smart.
I'm going to openly tell you right now, if you do not start with the angular momentum quantum number here, you
You'll
will miss
die.
this one.
Guys, oh my goodness.
You're going to find out why. When we look at this angular momentum quantum number, L is 2. What does that tell me? What block am I in?
D block.
Oh my goodness.
We're in D block.
Shout out D block.
Now I've narrowed it down to one block on the periodic table. Now I jump back up to the principal quantum number. So I'm using N. N, principal quantum number, shows me what? The row on the periodic table, but I'm in D block.
It's the 5th row.
I'm no longer looking for N, I have N. Now I'm looking for row. Do some math.
It's the 5th row.
I'm subtracting one from row. I want row by itself. I now have to add one. So for D block,
Row minus 1.
when we're trying to find row, the row is equal to N plus 1. So I add 1 here, and that tells me I'm in the 5th row. As many of you were signing to me.
I'm right. What'd you say?
I said in the 5th row.
Now,
I don't know what I thought you
we're in the 5th row, D block. I've narrowed it down to 10 elements. Now what I have to do, I have to figure out what two columns. M sub L tells me the column.
It's either gonna be 7 or 12, Mr. Hall.
Correct. So the 7th or the 12th column.
Oh.
How do I tell the difference? Spin quantum number. First half. So when we look at this, I'm in the first half, which means I'm on the 7th column of the D block in the 5th row, which tells me this is technically
What?
I'm not.
topic number 43.
Is that how you want us to write in the answers?
You can just give me the chemical symbol, or you can give me the name. I don't care. You don't have to put the atomic number. I put atomic numbers because you guys don't know where these things
I
are
need the
yet.
following students to report to lab 1110.
My nose
Now.
Behavior Conference, bring
1
that
out of
with you.
118%.
Here's the thing.
1 out
Doc
of
Browning,
118 chance to
David
guess.
Adams,
To me?
Noah Akers,
Do you see how this all connects?
Yeah.
Ariel Copley,
I will
Clark
give you
Klein,
an element, you give me 4 quantum numbers.
David Klein,
I'll give you 4
Jasmine
quantum numbers,
Day,
you give me an element.
Ethan Collins, Haley Klein,
What can I do to make this tricky?
Jacoby Lawrence,
It's the only thing I can
Alexia
do is here.
Hatfield, Isabella Kennedy,
Get you
Connor
mixed up here
Houston,
with the end.
Connor Lambert,
I'm not holding nothing back from you. I've showed you everything.
Will you,
Haley Jackson, Sean
will you be the
Hash,
type of fella to give us a set of quantum numbers that don't exist and expect us to
Logan
find out
Salmon,
that?
I give him my deals.
No. I'm the guy that there will be, just open and
Jacob
honest with
Kohler,
you.
Ashley
You
Thomas,
probably could bet on
Cameron
a
York,
section where I
Timothy
ask you,
Kohler,
determine if a set of quantum numbers can or
report
cannot
to lab
exist.
1110, please.
Besides that, determining whether they can or cannot exist, the other thing I'm going to do is I'll give you an element, ask for 4 quantum numbers, give you 4 quantum numbers and ask you for the element.
And-
This gives you everything that's possible for your quiz.
And I assume we'll also do electron configuration, like orbital,
What's up today?
And what do you need to know the difference of? Orbital notation, electron configuration, noble gas configuration. Because I will individually ask for them. And if you give me electron configuration for orbital notation, what do you think I'm going to do?
That's so goofy.
4,
I will look at you and say, that's not
Three.
orbital notation.
7,
Borrow your stapler,
I have
like
a
a
question.
Hey.
Listen to what this man is
Okay,
saying.
let me ask, orbital
Into those
notation
codes
is just
somewhere.
1s, 2s, the
20 minutes so you
lines
can
of it,
die.
right?
Lines and
Prepare.
arrows.
Okay.
You ain't gonna live forever, you stupid camera.
really
You're gonna
annoying.
die one
Numbers
day.
mean.
You're
That
gonna die
one, I feel like
in 20
electron
minutes.
is the most annoying.
Is he gonna remember you,
Questions?
camera? No.
Did she say math 11 too?
Yeah, you got ACA.
I have a question, Mr.
Yep, that's what.
Can you come look at my certificate?
Well, hey, I will not allow you to use the periodic table that I just showed you how to break down. I will not allow you to use that on your quiz. When I give you your periodic table to start your quiz, can you break it down? Absolutely.
The other day you said like the quantum world, some of the quantum world, so process wouldn't be, like, don't worry about it, it's just this part? Or is it just like the,
I'm not gonna be here
Oh,
Friday,
okay.
so it's either
I'm
I
not
take the
gonna worry
test
about it.
tomorrow, or I take it.
I will not ask you something on percent error, okay? I figured out a way to better explain that. I will not ask you something on percent error,
Replace one of the logic questions.
okay? I took a very simplistic concept and tried to turn it simple. And when I turned it simple and made it simple, I made it confusing.
Can I take,
Whenever we come back after break, that is what I will start with, and I will clarify that for you.
can I take the test tomorrow? I won't be here Friday, but it depends how confident I feel tomorrow.
I'm going to look at you and tell you that you're gonna want the day to practice.
Come on!
Okay? You're definitely
Cry about it.
practice now, bro.
You think?
Where you going to be Friday?
I got a bit
At what time?
No time.
Where's your dentist?
The one where Burger King is going to take me to work out.
Why?
What?
What's that
Where
place
Burger
called?
King
No.
is going to Beckley through Glen Fork.
Yeah, what's it, is it Skin Fork? I don't remember. No, Glen Daniels, it's in Glen Daniels.
Why do you go there?
Yeah, I got a Burger King to get my teeth checked out.
You can, if you wanna come, are you gonna watch, or are you gonna watch the
What?
play tomorrow?
I'll see, if I have to take the test, then no,
Okay.
but